Oh, welcome to Untitled where I fix stuff. So today you see a partially disassembled. This is a Hermes. I think it's a 167-12 fully automatic 4-function printing calculator. I just played with this a little bit before I turned the camera on, but I didn't really fix anything on it yet. So when I first got this machine, it didn't really work properly. The keyboard didn't really seem to do anything, and pressing plus, it would make the machine cycle, but it wouldn't actually print anything, and pressing minus would print all nines, and then pressing total and subtotal didn't really do anything either. So I just started poking around with it, poking some different things. I pushed one of these buttons, I think, to see what multiplication would do, and that set the machine into a never-ending cycle of just printing garbage. So I manually delatched the key to get it to come out of that cycle, and then I manually activated the motor bar just to get the machine to kind of reset itself, and after that it seemed to mostly work. So like I said, I didn't really fix anything. I just kind of randomly poked some stuff, tried some keys, and then after I got it out of that multiplication cycle, it mostly seems to work now. There are a few issues, we'll go into that, but it's like you can see, you can add. And you do a subtotal, and that's correct. And if you do a total, it does in fact clear it out, so that all works. You can do multiplication, so 625 times 625, and if you do equals S, see 365, so multiplication works now. And then that will leave, if you do equals S, that will leave it in, so if I do another subtotal, it's still in the accumulator. If I do equals T, it would print it and then clear it. You can do manually clear with a total, now it should be clear. Division, 3, whoops. So this is one of the issues. This doesn't always reset all the way, so then you have to give it a little click, and then it latches back. So if you watch when I do a clear, it shoves this is attached to the pegboard rack underneath, and shoves this all the way over, and they're supposed to spring back, ready to enter the next number. See, now I got stuck again. Sometimes it doesn't always clear all the way. See, that time it did. That time it did. So that's an issue that still has to be worked out. Anyway, we can do 355, add some zeros, and then we'll just add that into the accumulator, and then 113, and we can do divide S. So you got 3.141 is the first few digits. I only added a few zeros on the end of it, so that seems to work. I'm not sure about memory. I'm not exactly sure how the memory function is supposed to work on here. That's what this M key is for, which is pretty dirty, so you may even be told it's an M. So, let's clear this out. And if I push this down and I start adding, so now I've added a few digits there. If I do clear, it pops that back up. Now if I do a subtotal, see I've got the result there, and if I push down M and do a subtotal, I get the same. So I don't know exactly whether that's working or not, or what it's supposed to do. If I clear this out, and that's clear, I push down M again, if I do a subtotal, so I get nothing there. I get nothing there. So I'm not sure if this is working or not, or what exactly that's supposed to do. It doesn't seem to really have any effect that I can tell. So we do, oops, latch this down. Now if I do an empty plus, it clears that, but doesn't really print anything. See, now if I push M and hit plus, now I got my result that should have been cleared out. So I don't know if that's how it's supposed to work. Let me do that again and show you what exactly I'm doing here. So we'll clear that out. Memory seems to be cleared out. So if I latch down M and I do 1, 2, 3, And then I lift up M. So M is lifted up now. Do 4, 5, 6. This will be adding into the accumulator. So for the subtotal here, I have 5, 7, 9. Now if I do M and hit plus, still got 5, 7, 9. So I don't know exactly what that's supposed to be, but do subtotal. Oh, see, now it did add something in. So it looks like it added it into memory, and then when I had M latch down and hit plus, it added it from memory to there, I guess. Seems kind of weird. So clear that out. What's in memory now? Nothing. So seems odd that it would keep the same total. I don't know. Let's try that again. So I do 1, 2, 3 into memory, and then clear, and then so my subtotal is 1, 2, 3. Oh, now I do 1, 2, 3 again. So maybe if you do an empty plus, it just takes whatever's in memory and adds it back again. But I'm still not sure what the function of this key is. So that doubled it. We'll clear that out. So let's just try. Oops. 1, 2, 3. So now we got that. So now if I push M empty plus, it just adds it again. Okay, so that's not an effect of the memory, I don't think, because the memory key is up now. Apparently if you, that's interesting, if you just do an empty plus, it looks like it adds the accumulator to itself. That's an interesting feature. Clear that out. So let's see, if we do 5, add that in. So now I should have 4, 5, and I do. Okay, so I don't know if that's correct or what that's supposed to do, but it looks like if you just push, if you enter a number in the accumulator and then clear the keyboard, because the keyboard is cleared now, and then just do a plus with nothing entered, it just adds the accumulator to itself. Now I've got 20, so we do plus, it'll keep adding 20. Now it's 80. Now it'll add 80. That's interesting, actually. So it's not actually adding the accumulator to itself. Whatever the last subtotal is, that's what it adds. So now I hit a subtotal, I got 320, so now it's going to add 320. Yeah, so now it adds 320. If I do another subtotal, now I've got 1600, now it's going to add 1600. That's an interesting feature. So yeah, still not sure what the memory does, but I wonder if minus works for that too. How much is minus? Yeah, now it's going to subtract 1600. Huh, that's kind of cool. Anyway, yeah, so that's interesting, but I'm still not sure what this memory key is supposed to do. It doesn't seem to really have any effect that I can tell. But, so yeah, like I said, mostly works, few things to work out. This not clearing needs to be worked out. And this memory, what this is supposed to do, I need to work out and find out why it's not doing what it's supposed to be doing, whatever it's supposed to be doing. The number key seems to work. So if you want to do number, and then I do a subtotal, it didn't add, it just prints out the number. So that works. So yeah, like I said, mostly working. There is one thing else I wanted to point out. Initially when I got this, it wouldn't clear the keyboard. Whatever you entered, the keyboard would not clear, and would only go out to like the 6th position, and you couldn't enter beyond that. And the only thing that I did to affect that was, I can show this, it's all the way down here on the bottom. It's going to be hard to see. You can see this little lever here kind of wiggles up and down. Now when it clears the keyboard, this will drop down and hit this little peg up here. This is the keyboard return. So I'm not sure if you can see when I wiggle that. See how the pointer up there moves? Kind of moves back. So when it clears the keyboard, this bar will drop down and push that peg to the home position. Now when I got this machine, this bar was way up high, like way up, oops, not even showing, this is hard to show. This bar was like way up here, nowhere near where it could contact that peg. So there's a little flippy thing back here that I flipped. I'm flipping it now. So watch that bar. See how it pops up? And when I flip that down, it pops back down. So that's all that I did. I just flipped that. Now, what that does or what that means, I have absolutely no idea. Whether that thing is supposed to be always flipped down, and drawing and shipping flipped it up, and that's incorrect. So it's supposed to be flipped down. I really don't know. Whether it flipped down like that, everything seems to function perfectly, aside from memory. So yeah, I really don't know what the deal is with that. So I'll have to do some looking into what that actually is a part of and what could or could not flip that. But yeah, so that's just a little introduction here, a little bit of a demo, and kind of where I am on the status with this machine. So I'm going to see if I can figure out those issues, and then I'll try and do a little bit of explanation of what I figured out and how I think this thing works. At least, as far as you can tell, it's kind of hard to see how everything works in something like this, simply because, like over here, this whole width of the machine is nothing but layer upon layer upon layer of levers. So it's really hard to see, all the way in there to see what exactly each thing does. But kind of by wiggling things and watching things, you can usually get an idea of, if something's stuck or something's not engaging, with your particular function that you're trying to work on. So like for this memory thing, I'll be watching, when I push this key, what engages, if I can see something that looks like it should be engaging but isn't when I push this down. That's the kind of stuff that I look for. Something super complex like this that you really can't exactly see how everything works. Just gonna have to work on each function individually and see, what's attached to this key, what it should engage, what it looks like it might engage, what it looks like it might be out of place or disengaged or different stuff like that. But so yeah, so far not too bad. Like I said, the only thing that I actually changed was flipping that down, and that's where we are. So like I said, I'll see if I can figure out why this gets stuck and what this memory is supposed to do, and we'll go from there. Alright, so I think the memory might actually be working. I just wasn't quite sure how to use it. It looks like whatever the last thing that gets printed automatically gets saved in memory, and then if you latch this down, it will kind of like prevent that from being overwritten. So like if I printed out, say I printed out this total, I wanted to save that in memory, I would latch this down and it would lock that number in memory from being overwritten. So for example, let's see, we should be cleared out here. So if I do something like 1, 2, 3, 4, 5, 6, whatever the last thing that was printed, so right now 4, 5, 6 should be what's in memory. So if I put plus, that's going to keep printing that. If I had instead of wanting to save 1, 2, 3 in memory, I would have latched this down right after printing 1, 2, 3. So let's clear this out. That's clear, and then if I do 1, 2, 3, and then I latch that down, and then do 4, 5, 6, and now if I do plus, I should get 1, 2, 3, and I do. So I read that 1, 2, 3 back from memory. So that's how that works, and it seems to work. Now you notice that when I did the plus and read the 1, 2, 3 from memory, it released this, which will clear the memory. If you don't want that to happen, you flip this lever up, and then it'll lock that down. So it'll always do that. And I guess the way that you can use that is, if you want to do something like sum of quotients or something, like say we had, should be cleared out, still have to fix that yet, but say we had 100, and I wanted to divide by 5. So we got our answer there. We should be able to latch that down in memory. And then if we had something like 35 divided by 7, so now that should be 5. So now if I push plus, it adds that back in, and the subtotal, well, that's why it did divide total instead of divide subtotal. Okay, so I messed up. But as you can see, it saved that first result, the 20, into memory, and then I was able to recall that after the second division. I think in multiplication you wouldn't have to use that because you can just use the subtotal, but for division you have to enter the dividend into the main accumulator first, where multiplication you put it directly into the multiply register. So for multiplication, like sum of products, you may not have to use memory, but for sum of quotients, looks like you would have to. So let's try that again, see if we can get it right this time. So let's clear this out. So I wanted to do 100 divided by 5, and then this will be hash that into memory, and then I wanted to do 35 divided by 7, and this will be a subtotal. Now if I do plus, I get my first result back, and now if I do a subtotal, there we go. So now 25 is the sum of the two quotients. So yeah, memory seems to be working fine actually. So I still have to see about clearing this out, and then I'll probably go over a little bit of this machine, just point out some noticeable features. But yeah, it seems to be working pretty much fine, except for this. And subtraction works as well, so you can do something like minus 17. We get 8. Yeah, that's correct. So subtraction also works. So yeah, just took a little bit of time to figure out how exactly that worked. It's kind of a weird way to use memory, but it seems to be working fine. And just in case you couldn't really see the tape, what we did was 100 divided by 5 gives a quotient of 20, and then 35 divided by 7 gives a quotient of 5, and then the sum of those two quotients is 25. That's how we use the memory there. So I'm trying to get some oil into the sliding pegboard assembly, see if that'll help it to stop sticking. But the problem is you really can't see in there. So this is a view from the bottom. You can see the motor right there. If we look in here, behind here is where the pegboard assembly is. You can see, these teeth here are the bottoms of the racks that will come down to hit the pins, I believe. Either these racks themselves or some attachment to them. As you see, these are the main racks. They go all the way up, and then you can see them again up here, or part of them. I'm not sure if these parts can disengage with those parts or what, because you can see that here, this looks to be one register, and then, not sure you can see, but right here, there you can just barely see some gears. That looks to be another register. So either the racks can like disengage somehow, or they just disengage the registers from the racks to use one register but not affect the contents of the other. Not sure if there would be another register. I kind of think there would be a counter somewhere. So you'd have at least one main accumulator, and then one counter for multiplication and division, and then you probably also have to have a separate register for memory. I don't see how they could get away without using another register somewhere for memory, so I'm not quite sure where that register would be, or even the function of what these two are, which one is the main accumulator and which one, what the other one would be. Probably one of these is the main accumulator, but yeah. And I see what I was talking about earlier about up here, how it's just layer upon layer of levers, so you really can't get, just looking at that, you really can't see exactly what's going on. You just have to look at one function at a time and try and wiggle the key and see which parts in here wiggle, and try and follow the connections back and see, one part looks like it should be moving and it's not, or there's a spring that looks like it's been disconnected or something. Just gotta work it out. Luckily on this machine so far we didn't really have to do that. Everything seemed to kind of just loosen up on its own by playing around with it and experimenting. So far this machine hasn't been too bad. Hopefully it'll, basically it works. The only thing that really doesn't work so far is the pegboard getting stuck sometimes. But you know, like I said, can't really see in there. And then on the front here, and you can just barely see, so you can just barely see right in there. See those like faint 2 little pieces of metal? Get it to focus in on that. There you go. So the focus is, yeah, so you can just see all the way in the back there. If I can get my poker in here without poking the camera. Right there, those are 2 pegs on the pegboard. So yeah, looking through that little tiny crack, that's about all the view that you get of the pegboard assembly. Now with that, right now the pegboard's all the way out, so I entered in all the keys to get it to slide all the way out. See if I could see anything from, you know, from this side of it, but you really can't see into there at all. And it was in the home position. I was able to oil the top rail. If you have the pegboard, you know, slid back to the home position, you can look through there and see the top rail of the pegboard. So I got some oil on that, but I can't see the bottom rail at all. Usually there'll be 2 rails, just 2 round pieces of steel that the pegboard will slide back and forth on. So there'll be one running, you know, across this way down at the bottom, and then the same thing at the top. Like I said, I was able to see the top one and get oil on that, but I can't see the bottom one at all. There's some other contraption in the front here, which is related to these pieces, so that may or may not be the memory register. Can't really tell what's in there because everything's so enclosed. So yeah, I'm just going to keep playing around with this, see if I can get some more oil into that assembly, so I can get it to slide freely. It seems to slide, you know, decent when you're entering numbers. It doesn't get stuck. It's just at the very back end. So I was going to keep seeing if I can loosen that up, and then I think this machine will be pretty much done. So even after oiling, we're still kind of sticking. So what I did was, you see when it clears, this piece here falls back against this post and it's supposed to spring back to this position. And if you look closely here, you can see there's a little bit of maybe some crumbs here that suggest that maybe there used to be some kind of rubber boot on this piece, possibly. So what I did was I just put a rubber band, just like 1 loop around, and then, you know, just because it was too long, I stretched it up to here, just to give it a little bit of bounce back off this post. And so far it seems to work. You can see how it comes back, hits that post, and then goes back to its forward position. So we'll see how that goes, and if that will, you know, reliably solve our problem with the sticking. So also, you can see that the machine connects to the base by these little tabs here. It's actually kind of nice. So they have a rubber standoff and the post in the middle, and then the frame here sits on top of that with the post going through the hole. And then just have these little, they're basically C-clips, but they have this nice little tab on them, and that just snaps on there to hold the machine in. So there's 2 in the front and 3 in the back. That's kind of nice. The main case is held on by 4 screws that go in, you know, 2 on each side. But it's pretty nice that they have it so that you don't have to fiddle with screws to get the machine out of the bottom. That's kind of cool. Anyway, before I put the top case on, I figured I'd show the mechanism while the machine is doing a division. So let's enter something here. And then see if we can catch some shots of it going here. So I'll hit the divide key now. And see if I can show the back when my tripod's in the way. Try that once more. The better view of the back, maybe. I'll set it up. There's not really much to see on the front or the other side. The other side is just the motor, so you can't really see anything on that side. So if we can, in here, just get a nice little shot of it in action. And there you go. And there's the result, 3.141592. Now, of course, that's one point you have to set manually. Actually, I'll have to clean that. 3.141592. So yeah, hopefully that will solve our problem of the clear sticking with that rubber band on there. And I'll finish putting this back together. I do still have to clean up. My tripod is not cooperating here. I do still have to clean up the case. You can see it's pretty dirty for the top piece there, and this piece isn't too bad, but it does need a bit of cleaning. That just goes on like that. But so I'll first clean this up, and then we'll put it back together and do one last demonstration. Alright, so we're back together now. Cleaned up okay. It is slightly yellow, and you can see it's kind of stained here. Someone did have some random stickers that were mostly peeled off that I cleaned off. Not like, you know, like the seller's information. I mean, not the seller's information. Like, not like Hermes stickers or like, you know, service stickers or anything. There is one service sticker on the back. But the stickers that were up here on the front were, you know, just someone playing around putting random stuff on. You can see on the back here we've got a service sticker for Essential Office Products. It's probably who sold this machine and maybe who serviced it as well. But the stickers that were on the front were not those. They were just like random garbage, like kid stickers. Anyway, as you may or may not have noticed, the cord is in kind of sad shape. It looks like only the outer jacket has pulled out. The internal wires seem to be okay. I don't notice any cracks or anything on there, but I just have to watch that. I would replace this cord, except that this is riveted together on either side, so and even then it may not come apart. It may just be, you know, molded this way. This may not actually be like a separating seam. It may just be like the mold seam. So and this is not a standard plug, at least not that I'm aware of. So with this for now, I just have to watch and see if the wires start to the insulation starts to fail on those wires. But for now, we'll just run with it. Plug this in. Because the machine is mounted on rubber, and there's actually some rubber on the sides of the case too, it makes it kind of like jiggly, so you can wiggle the machine separate from the case. Not sure if that's really showing on the video, but anyway, you can see that little yellow pointer moves across, show you how much you've entered. And there we go. So that's addition. And that's subtraction. So we can do, sorry, memory engage. Let's clear out that memory. I didn't realize that was pushed down, but anyway, that's just some random garbage in the memory there. Clear that out. Number works. So we entered a number, but nothing's actually entered in the accumulator. You can see it's still 0. So we can do 625 times 625. $306.25. That should be cleared out. So we can do 355, and we'll enter a bunch of zeros. 113. We can do division. You can see as it divides, it walks the keyboard back across to do its repetitive subtractions in each column. You can see there, where you've got everything pointed out. So there's our addition up at the top there, and then subtraction, and then multiplication, and then the division. And you can see it prints out the, in case you're like adding some numbers, it prints out the subtotal first before it starts the division, then the divisor, and then this is the remainder with the t next to it, and then has a little QT next to quotient. So if you do a subtotal, this I believe says R or something instead of T if you just do the subtotal division. But yeah, so pretty satisfied with that. It's a nice little machine actually. It's I don't know if it's like volumetrically smaller, but it just feels smaller than like the Lego Machino Tortelli or the Olivetti di Visuma, just because those machines are like so high, they have like that big lump in the middle. But yeah, this is a pretty cool machine. Seems to be working fine. And the only thing that we really did to this was, the cleaning obviously. I added that rubber band that seems to have helped with the clearing thing sticking. Actually seems to have solved it actually. It hasn't happened since I installed that. Before it was happening semi-regularly. So just installed that rubber band and flipped down that one thing that I pointed out in the inside there, that little bar that flipped up and down. I just flipped that down and everything seems to work fine after that. So how that got flipped up, I have no idea. If there's like some valid case where it can get flipped up and then it never got flipped back down, I really don't know. Or if being flipped up like that is an invalid position, then just happened to get there through jarring during shipping or what, I don't really know. But seems to work fine. Everything seems to work. We demonstrated memory earlier, but I can do that again. So for example, if I wanted to do something like 100 divided by 5, so we'll do a total divide, and we'll save that in memory. So our quotient will be saved in memory. And then we'll do 35 divided by 7. Actually, I was supposed to do a subtotal there. Let's try that again. Let's clear this out. Let's try that again. I pressed total instead of subtotal. So we'll do 100 divided by 5. Yes, and do total. Save that in memory. And then we'll do 35 divided by 7, and this time we'll do a subtotal so it doesn't clear out the result. And now, if we do a plus, it should add our saved quotient, which it did, 20. Now if we do a total, we've got 25, which is the sum of our two quotients. So as you see, ignore the top part of here, we'll start here. We did 100 divided by 5 and got 20 for our first quotient. And then we did 35 divided by 7 and got 5 for our second quotient. And the sum of those two quotients is 25. You can see there the 20 pulled back out from memory, and we got our sum there, 25, sum of quotients. So yeah. Nothing else I have to say about this. This is a cool little machine. I think this is from like 63, around there. I could be wrong about that. But either way, this is, close to the end, relatively. These mechanical machines pretty much weren't really sold, I don't think, much past 1970. And of course, the first transistorized ones hit the market in 1964. So if this is 63, this is like 1 year before. I don't remember the exact date, but I think it's somewhere around there. Definitely in the 60s, not before 1960. Anyway, that's about it. I hope you enjoyed this video, and thank you for watching.